Welcome back to this session on central difference interpolation formulae. In the previous sessions, we discussed 4 central difference interpolation formulae. Here, we shall discuss the last one, namely Laplace-Everett interpolation formula, which can be used to interpolate near the middle value of a given data. We know that the Gauss forward interpolation formula y is equal to y naught plus u c1 into delta y naught plus u c2 into delta square y minus 1 plus u plus 1 c3 into delta cube y minus 1 plus u plus 1 c4 into delta raised to 4 y minus 2 plus u plus 2 c5 into delta raised to 5 y minus 2 plus u plus 2 c6 into delta raised to 6 y minus 3 plus etc. In this expression, we use delta y naught is equal to y1 minus y naught, delta cube y minus 1 as, we can write delta cube y minus 1 as delta square y naught minus delta square y minus 1. Delta raised to 5 y minus 2 can be written as delta raised to 4 y minus 1 minus delta raised to 4 y minus 2. And so on. Then this formula will become y is equal to y naught plus u c1 into delta y naught is y1 minus y naught, that is u c1 into y1 minus y naught plus u c2 into delta square y minus 1 plus u plus 1 c3 into delta cube y minus 1, which is equal to delta square y naught minus delta square y minus 1, u plus 1 c3 into delta square y naught minus delta square y minus 1 plus u plus 1 c4 into delta raised to 4 y minus 2 plus u plus 2 c5 into delta raised to 5 y minus 2, which is equal to delta raised to 4 y minus 1 minus delta raised to 4 y minus 2 plus u plus 2 c6 into delta raised to 6 y minus 3 plus etc. This is equal to here y naught, and in this second term which contains a y naught term. Therefore, we can combine these two, that is equal to 1 minus u c1 is u into y naught plus u c1 into y1, u c1 means u into y1 plus u c2 delta square y minus 1, here u plus 1 c3 delta square y minus 1, negative of u plus 1 c3 delta square y minus 1, combining these two terms containing delta square y minus 1, we can write u c2 minus u plus 1 c3 into delta square y minus 1 plus u plus 1 c3 delta square y naught the next term is plus u plus 1 C4 delta raised to 4 y minus 2. In this term, there is a term containing delta raised to 4 y minus 2. Combining these two terms containing delta raised to 4 y minus 2, we can write u plus 1 C4, here u plus 1 C4, in this u plus 2 negative of u plus 2 C5, this into delta raised to 4 y minus 2. Next is u plus 2 C5 delta raised to 4 y minus 1, u plus 2 C5 delta raised to 4 y minus 1 plus etc. Now, we have UCR plus UCR plus 1 can be written as UCR means u into u minus 1 into u minus 2 into etc. up to 2 into 1 divided by r factorial plus here u into u minus 1 into etc. up to 1 divided by r plus 1 factorial. We know that this sum is equal to u plus 1 C r plus 1. This is a general result, that is UCR plus UCR plus 1 is equal to u plus 1 C r plus 1. From this we can write UCR minus u plus 1 C r plus 1, which is equal to negative of u C r plus 1. Using this result, we can write this expression as y is equal to 1 minus u into y naught plus u into y1 plus here u C2 minus u plus 1 C3. Here r is equal to 2, therefore r plus 1 is 3. Therefore, by this result, we can write this as u negative of u C r plus 1 means in this case it is minus u C3 delta u C3. This is minus u C3 into delta square y minus 1 plus u plus 1 C3 delta square y naught plus this difference can be written as here r is equal to 4, therefore r plus 1 is 5. By using this result, we can write this as minus of u plus 1 C5. Here instead of u, it is u plus 1, therefore this is u plus 2. By using this result, we can write this difference as negative of u plus 1 C5, u plus 1 C5 into delta raised to 4 y minus 2 plus u plus 2 C5 delta raised to 4 y minus 1. Plus etc. Now, in this expression, we use the substitution 1 minus u is equal to v. Putting 1 minus u is equal to v, or u is equal to 1 minus v. Then u C3 will become u C3 is equal to u minus 1 u minus 2 divided by 3 factorial, which is equal to u is 1 minus v into u minus 1 means 1 minus v minus 1 into u minus 2 means 1 minus v minus 2 divided by 3 factorial, which is equal to 1 minus v into, this is 1 minus v minus 1 means minus v into, this is 1 minus 2 minus v, that is minus 1 minus v or minus v minus 1 divided by 3 factorial, which is equal to negative of, we can write this as minus of v minus 1 into v into, this is v plus 1 divided by 3 factorial, that is v plus 1 into v minus 1 means v plus 1 divided by 3 factorial means v plus 1 C3. Here is a negative, therefore, negative of v plus 1 C3. If we use this substitution, we can write u C3 as u C3 is equal to negative of v plus 1 C3. Similarly, this term u plus 1 C3 can be written as u plus 1 C3 or u plus 1 C5. This term u plus 1 C5 can be written as u plus 1 C5, which is equal to negative of v plus 1 C5, because u plus 1 C5 means u plus 1 into u minus 1 into u minus 2 into u minus 3 divided by 5 factorial, which is equal to, here u is 1 minus v, therefore, u plus 1 means minus v into u is 1 minus v into u minus 1 means, sorry, here u plus 1 means 2 minus v. U plus 1 means this plus 1, that is 2 minus v into u is 1 minus v into u minus 1 means 1 minus v minus 1, that is minus v. U minus 2 means 1 minus v minus 2, that is minus 2 minus v into u minus 3 means 1 minus v minus 3, that is, sorry, here minus 1 minus v, next is minus 2 minus v divided by 5 factorial. This is equal to, from here we can write minus of v minus 2. From this we can write v minus 1, minus of v minus 1 means plus, this minus v is again minus, minus of 1 minus v means v minus 1, sorry, v plus 1. If we take minus 1 outside, we can again this will become minus, and from this if we take minus 1 outside, we can write v plus 2, that is negative of v minus 2 into v minus 1 into v plus 1 into v plus 2 divided by 5 factorial means v plus 2, choose 5, v plus 2 C5, that is here is a negative sign, therefore, minus of v plus 2 C5. Similarly, we can write u plus 2 C5. Therefore, this expression for y can be written as y is equal to 1 minus u into y naught, that means 1 minus u is v into y naught plus u y1 minus UC3. UC3 is in terms of V, which is minus of V plus 1 C3. Therefore, here is a negative sign, it will become plus V plus 1 C3 into delta square y minus 1 plus U plus 1 C3 into delta square y naught. Here U plus 1 C5 can be written as negative of V plus 2 C5. Therefore, minus of minus will become plus. U plus 1 C5 is V plus 2 C5 into delta raised to 4 y minus 2 plus U plus 2 C5 into delta raised to 4 y minus 1 plus etc. That is y is equal to, this can be written as V into y naught plus V plus 1 C3 into delta square y minus 1 plus V plus 2 C5 into delta raised to 4 y minus 2 plus etc. That is, first we write all the terms containing V, this plus, then we are writing all the terms containing U, which are U y1, U into y1 plus U plus 1 C3 delta square y naught plus U plus 2 C5 into delta raised to 4 y minus 1 plus etc. That is, y is equal to V into y naught plus V plus 1 C3 means V plus 1 C3, which is equal to V into, V plus 1 into V minus 1 divided by 3 factorial, which is equal to V into V plus 1 into V minus 1 means V square minus 1 square divided by 3 factorial. Therefore, V plus 1 C3 into delta square y minus 1 is V into V square minus 1 square divided by 3 factorial into delta square y minus 1 plus V plus 2 C5. V plus 2 C5 means V plus 2 into V plus 1 into V minus 1 into 1, 2, 3, 4, one term is V minus 2 divided by 5 factorial, which is equal to V into, here V plus 1 into V minus 1 means V square minus 1 square, V plus 2 into V minus 2 means V square minus 2 square divided by 5 factorial. That is, V plus 2 C5 into delta raised to 4 y minus 2 means V into V square minus 1 square into V square minus 2 square divided by 5 factorial into delta raised to 4 y minus 2 plus etc. plus the terms containing U are U into y1 plus U plus 1 C3 means U into U square minus 1 square divided by 3 factorial into delta square y minus, delta square y naught. Next is U plus 2 C5 means u into, just like this we can write u into u square minus 1 square into u square minus 2 square divided by 5 factorial into delta raised to 4 y minus 1, delta raised to 4 y minus 1 plus etc. Here u is x minus x naught divided by h, and v is equal to 1 minus u. This formula is known as the Laplace-Everett interpolation formula. When we use this formula, in order to obtain better accuracy in the interpolating value, it is better to choose x naught such that the value of u lying between 0 and 1 and the value of v lying between 0 and 1. Now consider one example using this interpolation formula. We have to evaluate e raised to minus x when x is equal to 1.748. The given data is x values are 1.72, 1.73, 1.74, 1.75, 1.76 and 1.77, and the corresponding y values means here y is e raised to minus x, which are 0.1790, 0.1773, 0.1755, 0.1738, 0.1720, and the last one is 0.1703. These are the y values. From this data, we have to evaluate e raised to minus 1.748. We can use this Laplace-Everett interpolation formula because x equal to 1.748 is near to this central values. First of all, we form the difference table. This is the given data. Using this data, we form the difference table. First differences are, first order differences are 0.1773 minus 0.1790, which is negative 0.0017. Then 0.1755 minus 0.1773, which is again a negative value, minus 0.0018. Next difference is negative 0.0017. Then it is also negative 0018. Next is again negative 0.0017. These are the first order differences. The second order differences are delta square y, which are negative, that means minus 0.0018 minus negative 0.0017, which is equal to minus 0.00 3 zeros and 1, then 0.0001, next is minus 0.0001, and the last one is 0.001. These are the second order differences. The third order differences are delta cube y, which are 0.0002, next is negative 0.0002, then 0.0002. The fourth order differences are, first is minus 0.30 and 4, then this is 0.0004, and the fifth order difference is 0.0008. This is the corresponding difference table, and by this formula we can write y means y at x is equal to 1.748. Here u is equal to, we can choose x naught as 1.74. We can take this as x naught, that is x naught equal to 1.74. Then u is equal to x minus x naught divided by h is, here x is 1.748 minus x naught is 1.74 divided by h is here 1.73 minus 1.72 means 0.01, h is 0.01. Therefore, u is equal to 0.8 and v equal to, v means 1 minus u, that is 1 minus 0.8, which is equal to 0.2. Now, the required differences involved in this formula. Formula means in this first group all the terms are in V, that is V group, and in this second part all the expressions, all the terms are in U. Therefore, we enclosed the differences in this group, that is V group, in rectangular boxes, and those in the second group, that is the differences in the U group, are enclosed by ellipses. That is here y naught in this V group, first term is y naught, that is this is the value of y naught 0.1755. Here y1 in this U group, first term is u into y1, therefore, we have to use this value. Then next is delta square y minus 1 in the V group, which is this value negative 0.0001, and in this U group delta square y naught here, which is this value. The next term delta raised to 4 y minus 2, which is this one, and here delta raised to 4 y minus 1, this value. Using this the relevant differences and the values of u and v, we can write y of 1.748 as, this is equal to y of 1.748, which is equal to e raised to minus 1.748, because here the function is e raised to minus x, which is equal to v into y naught. V is 0.2 into y naught. Y naught is this value, this is x naught, therefore, this value is y naught, that is this into 0.1755 plus next is v into v square minus 1 square divided by 3 factorial, which is 0.2 into minus 0.96 into 0.0002. 0.0001 divided by 3 factorial is 6 plus 0.2 into this term v into v square minus 1 square into v square minus 2 square divided by 5 factorial into delta raised to 4 y minus 2 is 0.2 into minus 0.96 v square minus 1 square is minus 0.96 into v square minus 2 square, which is minus 3.96 because v is 0.2 into this divided by 5 factorial. 5 factorial means 120. This into delta raised to 4 y minus 2, which is minus 0.0004, that is minus 0.0004 plus this is the V group terms, and this plus the U group terms are U into y1, where U is 0.8, y1 is this value. Therefore, this plus 0.8 into 0.1738 plus 0.8 that is u into u square minus 1 square divided by 3 factorial into delta square y naught is 0.8 into negative 0.36 into negative 0.0001 divided by 3 factorial is 6 plus this is u into u square minus 1 square into u square minus 2 square divided by 5 factorial is 0.8 into negative 0.36 into negative 3.36 into 0.0004 divided by 5 factorial is 120. On simplification, we will get this as 0.1741 approximately. That is the value of e raised to minus 1.748 is equal to 0.1741 approximately. With this example, let me conclude this session. In this session, we derived the fifth central difference interpolation formula, namely Laplace-Everett interpolation formula. Hope that you have understood this session. Thank you for watching the class. Have a nice day.